Relations, Part 2. Today we're going to focus on graphing relations that are in two variables. So we're going to be plotting points using ordered pairs. But before we do that, let's just recap solving equations in one variable. So I've given you an equation in one variable. There's only one letter, and we're going to be solving for that letter. We're going to solve for x. So as a recap, the first thing we need to do is to eliminate the brackets. So we are going to expand. We are applying the distributive property and multiplying every term in this bracket by the 3 in front. So that gives us 3x minus 12. At this point, we need to transpose. So the 3x term needs to move to the opposite side, and the positive 1 needs to move to the opposite side. And when we transpose, we are using the concept of opposite operations. So here we are adding 1, and so when we move to the opposite side, we are subtracting 1. Here we are adding positive 3x, and when we transpose to the opposite side of the equation, we are subtracting 3x. Now that each side has like terms, we collect the like terms. So 2 take away 3 gives us a negative 1 as the numeric coefficient in front of the x. And the right-hand side simplifies to give us negative 13. Now we still need to isolate x. So right now at this step, this is saying negative 1 multiplied by x. So the opposite of multiplying by negative 1 is to divide by negative 1. So we divide both sides by negative 1. And the right-hand side becomes negative 13 over negative 1 to give us positive 13. There is only one solution. And the reason there is only one solution is because we are working in only one variable. One letter, one variable, one solution. So in this case, x equals 13 is the only possible answer for this particular question. Next, we're moving on to equations in two variables. So that means we are going to be looking at two letters in our equation. So in this particular case, our equation is y equals 2x plus 1. We have the variable x as well as the variable y. When this happens, two variables, there will be an infinite number of solutions. In this case, solutions are often called ordered pairs. So we're going to be looking for pairs of numbers, x and y, that pair together to make this equation true. So what we're going to do is you are going to choose whatever value you wish for x. I'm going to keep it simple, and I'm going to choose x equals 1. That means I'm going to substitute x equals 1 into our equation. So I've copied the equation from above, but I have replaced the x value with 1, and I've put it in some brackets. So now this becomes 2 times 1 to give us 2, add the 1 to give us 3. So when x is equal to 1, its corresponding partner is y equals 3. And we can now express that as an ordered pair. So the pair 1, 3 is a solution to this particular equation. But I mentioned there are many more solutions. So what we're going to do is we're going to organize some pairs of numbers in a table of values. So I have put together a table of values, and I have chosen different values for x. Okay, I like to pick one value for x that's negative. I also like to always include x equals 0. And then I pick some smaller values like 1, 2, and 3. Because I want to keep my calculations nice and simple. Now we've already said that 1, 3 is a solution, so I can fill in when x is 1, the corresponding value is for y is 3. So I want to complete this chart. So I'm going to find the corresponding value for when x is equal to negative 1. So I want to find its partner y. So I have to substitute x equals negative 1 into the equation and solve for y. I'm showing you this on the next paper. So if we shift down to the next sheet, take a moment to focus here. Okay, so I have replaced the x value with negative 1. I multiply to get negative 2, and then I add the 1. so that y is equal to -1. So that corresponds to the ordered pair -1, -1. It's also a solution. So I go through and I repeat this process for all the other x values in the table. And to save time, I've summarized the y values here. And so once you have your x and your corresponding y value, you can express that as an ordered pair. Once I have my ordered pairs, I can then graph the relations. And for some reason, the scale is not showing up. And for simplicity, I have consistently used a scale of 1, okay? And so now I have plotted these ordered pairs, and you can see that they do form a pattern, which is, again, what I'm expecting because I have been following the rule consistently. Now we're going to look at a second example, but this time I want to look at fractions. Okay, so in our next example, we're going to be graphing the relation y equals 1/3 x minus 4. And to do that, we're going to make a table of values so that we come up with 5 ordered pairs that make this equation true. Now, we're just going to change the format a little bit. So when you see 1/3 times x, that's a third times x, but it's also the same thing as x over 3, which means x divided by 3. So I'm just going to rewrite that term as x over 3. So now, to find y, you have to take the x value divided by 3, because I'm following order of operation, division first, followed by subtraction. So whatever number I pick for x, I have to divide it by 3. So we're going to plan ahead and use some strategy here. I want to pick numbers that are divisible by 3, which means I have to pick values for x that are multiples of 3. Okay, so I've chosen x values that are negative as well as positive, and they are all multiples of 3. Okay, and by doing that, I'm planning ahead so that when I take the number -6 and I divide it by 3, I'm going to get an integer. -6 over 3 is going to give us -2. So I'm planning ahead to avoid fractions. Okay, so I have shown you down below all the substitutions and all the simplifications to show you how the ordered pairs are created. Now, I did make one mistake. I forgot to put brackets. I have told my students over and over again, when you substitute in a value, you should put that number inside some brackets. So I'm going to add some brackets. So -6 divided by 3 is -2. Subtract 4 to get -6. So down below, that becomes the ordered pair -6, -6. Okay, and then when x is -3, and we divide that by 3 to get -1, then you subtract 4 to get -5. And 0 divided by 3 is equal to 0. Anytime you take 0 and you divide it by a number, the answer is 0. So 0 take away 4 is equal to -4, and then we deal with the positive numbers. So now I've done 1, 2, 3, 4, 5 different substitutions for x. I found their corresponding partner y, and now I have 5 sets of ordered pairs that satisfy our equation. These numbers, these groupings, or pairs of numbers, make our equation true. And now we're going to graph these. So -6, -6, -3, 1, 2, 3, -5, 0 and -4, 3 and -3, 6 and -2. And I'm very happy with the results because I can see a pattern emerging here. When I see this visually in a graphical representation, the points all line up. There's a definite pattern to the way these points are arranged on the graph, so I know that there is a relation between x and y.